and today I'm going to be looking at a rather simple question and an idea that I think lots of people just seem to accept, and indeed I probably did accept for quite a long time, but it is, why do the angles of a triangle actually sum to 180 degrees? And to do that, I'm going to look at a couple rules of parallel lines first, and a couple what are known as Euclidean axioms, which kind of define typical geometry the way we learn it from primary school, and establish and prove these rules of parallel lines, which are also just seemingly accepted, and then using them to prove that the angles of a triangle do sum to 180 degrees. My first axiom, axiom 1, as I'm going to call it, is that the angles in a straight line sum to 180 degrees. The sum of all these angles will have to equal 180 degrees. This is my first Euclidean axiom that I'm going to care about for this video, and you might be able to see why, 180 degrees. And the second axiom is a bit more nuanced and looks much more complicated, but it isn't too complicated. And that's sometimes known as the parallel axiom. And it states that, say I've got two lines, A and B, which I'm going to call A and B, and you've got a straight line, these are all straight lines by the way, that cuts both those lines. If the straight line cuts both those lines such that this angle X and this angle Y are less than 180 degrees, then A and B meet on the side of X and Y. And an axiom, I should add, is something that can't quite be proved but has to be assumed for us to make progress. They're almost defining properties. So they're a bit like Newton's laws in physics. So say I mark these other two angles as what they are. By axiom 1, this is going to be 180 minus X and 180 minus Y. So by axiom 2, and this is going to lead into why co-interior angles sum to 180 degrees, because co-interior angles are X and Y. If X and Y are less than 180 degrees, we get that these two lines will meet on this side. So X plus Y has to be greater than or equal to 180 degrees, correct? But similarly, 180 minus X plus 180 minus Y, since the two lines are, if A and B are parallel, then obviously X plus Y is greater than or equal to 180 degrees. But also, since parallel lines don't meet on either side, we don't get intersection of the two lines here or here. That means 180 minus X plus 180 minus Y is going to be greater than or equal to 180 degrees. And so if I rearrange this implies that 360 minus X minus Y is greater than or equal to 180 degrees. I should add X plus Y, because we move those across to the other side, is less than or equal to 180 degrees. So we've got two identities. X plus Y is greater than or equal to 180 degrees, but also X plus Y has to be less than or equal to 180 degrees. The only solution to this is X plus Y is equal to 180 degrees. This implies that co-interior angles do sum to 180 degrees. Well, in truth, this is probably enough, combined with axiom 1, to prove that the angles of a triangle sum to 180 degrees. But I'm going to try to prove all of the rules of parallel lines for a bit of completeness. So my second rule is alternate angles are equal. And to prove this, well, I'll prove this here. So you've got two parallel lines and a line cutting across or intersecting both lines. I'm going to let this angle be angle X. Now, I'll label this as y and z. So by rule 1, which has been proved, y is equal to 180 minus x. Therefore, by 2, or axiom 2 rather, by axiom 2, we've got x is, or y plus z is equal to 180 degrees. So we've got 180 minus x plus z is equal to 180. And now, this implies that 180 minus x plus z is equal to 0 because we can take away 180 from both sides, which implies x is equal to z. And so we prove this. So our final rule for parallel lines is corresponding angles are equal. Well, let's draw our lines, and I want to intersect here. And I want to prove that this angle is equal to this angle. So I'm going to let this angle equal x, as I've done before. So here, and I'm going to verbally speak through this proof. Here, that means by alternate angles, this is equal to x. Opposite angles are equal, but I'm not just going to state that, I'm going to prove it. And I'll prove that as a little subset here. I'm going to use axiom 1. That's this angle, what I'm going to call y. And I'm going to let this angle be z again. By axiom 1, x plus y is equal to 180 degrees and y plus z is equal to 180 degrees. By rearranging, you get 180 minus x is equal to 180 minus z, or x is equal to z. Therefore, x is equal to x. Corresponding angles are equal. Okay, so for why do angles of a triangle sum to 180 degrees? We've got this angle, let's let this angle be A, this angle is B, and this angle is C. By alternate angles, this is B. Again, by alternate angles, this is C. So, and then by axiom 2, or axiom 1, I keep putting axiom 2. And by axiom 1, A plus B plus C is equal to 180 degrees. Therefore, the angles of a triangle sum to 180 degrees. And we are done. And we've proved all the parallel rules of parallel lines we've got, or laws, or theorems, which are proved solely from axiom 1, angles in a straight line summing to 180 degrees, and this complicated looking parallel axiom. So hopefully this was a nice and interesting video where I've gone from the real basics of geometry, which probably aren't even covered. I don't remember being covered in school. Please make sure to comment down below if you have any queries, and yeah, thanks for watching.